Hello, we are starting Unit 59, Areas of Circles, Sectors and Segments. First, let's see two formulas for the area of a circle. The first formula can be used when we are given the radius, and the formula is A equals pi r squared. The second formula can be used when we are given the diameter, and the formula is A equals pi times d squared over 4. You may be familiar with the first formula, but let's see how the second formula is related to the first one. We know that the radius is half of the diameter, and in the formula A equals pi r squared, let's replace r with diameter divided by 2. So we will have A equals pi, and in place of r inside the parentheses we will write diameter divided by 2 and all squared. From here we continue and we get A equals pi, and now we have to raise this fraction to the second power. To raise a fraction to the second power, we raise the numerator to the second power and then the denominator to the second power. So d squared is on the numerator and 2 squared, which makes 4, is on the denominator. So this is how we get this second formula. Now let's talk about the area of a sector and the area of a segment. Recall that a sector is a region formed by two radii and the intercepted arc. The formula for the area of a sector is A equals theta divided by 360 degrees multiplied by pi r squared. The fraction in front of pi r squared tells us how much of the whole area of a circle we are finding. For example, if theta is 90 degrees, then 90 degrees over 360 degrees is 1/4 of the area of the circle. The last formula is the area of a segment. A segment is a region formed by the arc and the chord joining the endpoints of the arc. If you look at the given figure, then that is the shaded area that you see there. To find the area of the segment, we have to take the area of the sector and subtract the area of the triangle. In this given figure, the sector is given by the letters O, A, C, and B, and the triangle is given by the letters A, O, B. So if we subtract the area of the triangle from the area of the sector, we will get the area of the segment. Now let's solve some exercises. In this exercise, we are given the area of a circle, and the area is 380 millimeters squared. We have to find the radius and the diameter of this circle. We know that the formula for the area of a circle is A equals pi r squared. To find r, we can replace A with 380 and solve for r. So 380 equals pi r squared. Let's divide both sides by pi. On the right side, pi and pi will cancel. If it helps, we can write r squared on the left side and 380 over pi on the right side. To find r, we have to take the square root of the right side. And I would keep the right side as a fraction until the last part when I put everything in the calculator. So r equals square root of 380 over pi. On some of your calculators, you may need to use parentheses inside the square root. So your typing is going to look like this: square root, parentheses, 380 divided by pi, close the parentheses, and make sure all this is inside the square root. So then r equals 10.99807 and so on. And let's round this to 1 decimal place. Because in the tens place we have a 9 and to the right we have another 9. When we round this to 1 decimal place, the result will be 11.0. And the units will be millimeters. So this is one answer. We got the radius. Now we have to get the diameter. The diameter is twice the radius. So to find the diameter, we take the radius and we multiply by 2. So we get that the diameter is 22.0 millimeters. Now let's see another problem. A rectangular steel plate 15.10 inches long and 12.45 inches wide weighs 19.4 pounds. Find the weight of the plate after 3 4.65 inch diameter holes are cut. We will also round the final answer to the nearest tenth pound. Let's start by drawing the plate and the holes that will be removed. So here we have the plate with the given dimensions and the 3 holes that are cut. Also, each of these holes has the diameter of 4.65 inches. First, let's find the area of this plate before cutting the holes. So area equals 15.10 multiplied by 12.45, and this will give us 187.995 inches squared. Now let's find the weight of the plate per square inch. For this, we will divide the total weight by the total area. So the total weight is 19.4 pounds. Let's write this in the numerator. Divided by total area is 187.995 square inches. This will give us approximately 0.103194 pounds per square inch. Now let's find the area of this plate after removing the holes. For this, we will take the whole area, which we found to be 187.995, and subtract the area of the 3 holes. So 3 times, and now because each hole is a circle, we will use the formula for the area of a circle. And because we are given the diameter of each circle, then we will start with pi and multiply by diameter, which is 4.65 squared divided by 4. So we took the whole area and we are subtracting the areas of 3 holes. With the use of a calculator, we will get that this area is approximately 137.0481 square inches. So again, 187.995 represents the total area, 3 represents the 3 holes, and pi times 4.65 squared over 4 represents the area of a circle using the formula pi times diameter squared over 4. And now finally we can find the weight after cutting the holes. So down here to the left we found how many pounds per each square inch we have, and to the right we have the number of square inches, and if we multiply these two numbers we will find the weight of the plate after cutting the holes. So then 0.1031 1,031,94 multiplied by 137.0481 will give us approximately 14.1 pounds. We said in the beginning that we will round this answer to the nearest tenth of a pound. So this is the weight of the plate after removing the holes. Here we are given a figure and we have to find the area of this figure. It looks like on the left side we see half of a circle, then in the middle we see a rectangle and a trapezoid, and to the right we see another half of a circle. Let's give each of these regions a name so we will know what figure we are working on. So let's call this figure 1. This one will be the second, this one will be the third, and this one will be the fourth. Below, I will start the area of the entire figure. So the area of the entire figure is gonna be made of the areas of these four figures. So the first figure is half of a circle with the radius 3.2. We know that the formula for the area of a circle when we know the radius is pi r squared, so we just have to take pi r squared and divide by 2. And in place of r, we will write 3.2. So pi times 3.2 squared divided by 2. So this is the area of the first region. Now let's add the area of the second region. The second region represents a rectangle with the sides 3.2 and 4.5. And to find the area, we will multiply these two sides. So 3.2 times 4.5. So this is the area of the second region. Now let's work on the area of the third region. This region is a trapezoid, and let's recall the formula for the area of a trapezoid. The formula is A equals height divided by 2 multiplied by the lower base plus the upper base. Now imagine that this is a trapezoid that is rotated 90 degrees counterclockwise and the height is 3 units. The upper base is 3.2 and the lower base is twice this radius, 5.7, which makes 11.4. Let's add all this in the total area below. So the height 3 divided by 2 times, in parentheses, the lower base is 11.4 plus the upper base is 3.2. And now we need the area of the fourth region. This is a half circle with the radius 5.7. Therefore, the area is pi multiplied by 5.7 squared, all divided by 2, because we need half of a circle. With the use of a calculator, we should get that the total area equals 103.4 square inches. And that is if we round to the nearest tens. Here we have another problem where the radius of a circle is given and the radius is 20.25 inches. We are also given the area of a sector, which is 1028 square inches. We have to find the central angle. So we know that the area of a sector is given by the formula A equals theta, which is the central angle, divided by 360 degrees, multiplied by the area of the circle, which is pi r squared. In this formula, we will replace A with 1028 and R with 20.25 and we will solve it for theta. So in place of a, let's write 1028 equals theta divided by 360 multiplied by pi, and in place of r, 20.25 squared. Let's multiply both sides by 360 to remove the fraction. So multiply the left side by 360 and the right side by 360, and on the right side 360 will cancel. I will continue solving for theta, and I will do all the operations at the end with the use of a calculator. So let's rewrite 360 multiplied by 1028 equals theta multiplied by pi times 20.25 squared. To solve for theta, we will divide both sides by pi times 20.25 squared. On the right side, we will cancel pi times 20.25 squared. And now we have that theta equals 360 times 1028 divided by pi times 20.25 squared. And here we can get the answer by using a calculator. Just make sure that on some calculators, when you type all in one row, you may need extra parentheses on the numerator and extra parentheses on the denominator. Theta equals approximately 287.3 degrees. So if I would draw this sector in the circle to the left, it would look approximately like this. And the central angle would be 287.3 degrees. Here we have another figure, and we have to find the area. This figure consists of a sector, a rectangle, 1/4 of a circle, and another rectangle. Let's name each of these regions. Let the sector be region 1, the rectangle be region 2, the fourth of the circle be region 3, and the other rectangle be region 4. We will find the area of each region, and we will add the areas together to get the total area. To find the area of the sector, we need to know the angle and the radius. First, let's find the angle. We see there is an angle of 137 degrees, but that angle is not the angle that belongs to the sector. We also see a 90-degree angle that is part of the rectangle of region 2. We need to find angle theta that is part of the sector. To find that angle, we will start with 360 degrees, that makes one full rotation, and subtract 137 and 90 degrees. Then theta equals 133 degrees. Let's add this angle to the figure. So inside this sector, this angle has 133 degrees. We also need to know the radius. To find the radius, we need to subtract 8.460 minus 4.640. Find these numbers in the figure and make sure you understand that by subtracting them, we get the radius. R equals 3.82. I will add this to the figure. So the radius is 3.82. Now I will start the total area, and the first part will be the area of the sector, that is 133 degrees over 360 degrees multiplied by pi r squared, and r is 3.82 squared, plus, now the second region is a rectangle, One side is 3.82, but the other side we will get by subtracting 15.810 and 3.820. The result is 1199. I will add this to the figure. So this side will be 1199. Now let's continue with the area. So the area of this rectangle is 3.82 multiplied by 11.99. Next, we see a fourth of a circle. So we will start with 1/4 multiplied by the area of the circle. The radius of this circle is also 3.82. So the area is pi times 3.82 squared. And now we have to add the area of region 4, which represents a rectangle. This rectangle has the dimensions 4.640 and 3.820. Let's multiply these two numbers to get the area. 4.640 times 3.820. Let's use the calculator and get the total area to be approximately 91.9 square units. And if the initial dimensions were, let's say, in inches, then the area would be 91.9 square inches. And we just finished solving this problem. In this problem, we will find the area of a segment. And a segment is the region between the chord and the arc. Recall that the area of a segment equals the area of a sector minus the area of the triangle. First, let's find the area of the sector, then we will find the area of the triangle, then we will subtract them. So, the area of the sector equals, the angle is 150 degrees over 360 degrees multiplied by pi, radius squared, and radius is 6. So 6 squared. All this equals 47.124. And let all the dimensions be given in inches, then this area will be square inches. Now let's work on the area of the triangle. From the figure, we see that one side of the triangle is 6 and the height is 1.55. But it looks like we don't have the base yet. And the area of a triangle is 1/2 times base times height. So first, let's find the base of this triangle. In fact, first we will find half of the base by using the Pythagorean theorem. In the figure, let's call this half base x. Then x squared plus 1.55 squared equals 6 squared, according to Pythagorean theorem. X squared equals, we will subtract 1.55 squared on both sides and we will get 6 squared minus 1.55 squared. And then to find x, we will take the square root of the right side, 6 squared minus 1.55 squared. Then x is approximately 5.7963. Now the base of the triangle is twice x, 2 times 5.7963. And this equals to 11.5926. Now let's find the area of the triangle. So the area is 1/2 times base times height. The base is 11.5926 5,926. The height is 1.55. All this equals 8.984, and these will also be square inches. Now, to find the area of the segment, we will subtract the area of the sector minus the area of the triangle. The area of the sector is 47.124, and the area of the triangle is 8.984. If we subtract these two numbers, and let's say if we want to round this to one decimal place, then the result will be 38.1 square inches. This was the last problem for this unit, and this was Unit 59, Areas of Circles, Sectors, and Segments. Thank you for watching.